Hello everyone, my name is Shalom, and today I'll be doing 2012 Step 1 Question 5, so I hope you enjoy. I'm expecting visitors soon, so I hope I can clean this up before they come. So first, this is just like, there's not much thinking to do with these questions. It's just do the integration, at least for the first part. So we have to show that this integral gets this result. So we have the integral from 0 to power of sine 2x ln cos x dx. So this is immediately says to me integration by parts. So I'll choose my u to be ln cos x as it's a logarithm, and then so du would be using the chain rule, minus sine x times 1 over cos x equals minus tan x. And then dv is sine 2x, so v would be the integral, which is minus a half cos 2x. We need to find the integral I. I becomes minus a half cos 2x ln cos x from 0 to pi over 4 minus the integral from 0 to pi over 4 of minus a half cos 2x times minus tan x. So first let's evaluate the limits of this part. So at pi over 4, cos 2x is cos pi over 2, which is 0. And at 0, well, cos 2x is 1. And then, but cos x is also 1. But ln 1 is 0. So this would become 0 minus 0, which is just 0. And then minus the integral, where there's a double negative here. So that cancels out, and I'll take out the half. So that would become the integral 0 pi over 4 of cos 2x tan x. And that, what the hell is this? And now I want to use some double angle formula. So the one I want to use is that cos 2x equals 1 minus 2 cos squared x minus 1, and hopefully simplify this integral. I'm sure the other double angle formula for cos 2x would work, but that's just the one I used. Cos squared x minus 2 cos squared x minus 1 tan x dx. And now this, I can expand this to 2 cos squared x, and then I'm gonna write tan x as sin x over cos x to simplify this down, because there's a simplification here, and then minus tan x. And we can see here that cos x and cos squared x, one of the cos x's cancel out, so we'll be left with 2 cos x sin x. Minus tan x dx. And then recall that 2 sin x cos x is the double angle formula for 2 sin x. I mean sin 2x. So that is basically simplifying the integral to the integral of sine 2x minus tan x dx. And we know that the integral of minus tan x is ln cos x from early in the question. And the integral of sine 2x is minus a half cos 2x. So now we have minus a half cos 2x plus ln cos x from 0 to pi over 4. Well, at pi over 4, cos 2x is 0. Ln cos pi over 4 is 1 over root 2, and ln 1 over root 2, we can leave it as that for now. And then that minus at 0, cos 2x is cos of 0, which is 1. So minus a half times 1, which is minus a half, plus cos 0 is 1. So ln 1 is 0. So now we have this equals minus a half multiplied by ln 1 over root 2 minus a half, which is plus a half. And so in the final answer that the question wants it in, it has it in terms of ln 2. So we want ln 1 over root 2 in terms of ln 2. Well, 1 over root 2 is equal to 2 to the power of minus a half. So we can rewrite that as ln 2 to the minus a half. And then we can use our logarithm rules to write minus a half as the coefficient of the logarithm. And now we can factorize out minus a half. So that becomes a quarter ln 2 minus 1. And that is the final answer for the first part of the question. Now, a similar integral, the integral of from 0 to pi over 2 of cos 2x ln cos x, and we have to show that it yields that result. So let me define this integral j. J equals the integral from 0 to pi over 4 of cos 2x ln cos x dx. Now we're going to use a similar integration by parts here. So u equals ln cos x du equals minus tan x, and then v equals cos 2x. So v equals a half sine 2x. Now therefore j equals a half ln cos x from 0 to pi over 4 minus the integral from 0 to pi over 4 of v du, so a half sine 2x multiplied by minus tan x. Now first let's evaluate the limits of this. So at pi over 4, sine 2x is sine of pi over 2, which is 1, so that's a half, and then cos of pi over 4 is 1 over root 2, so that becomes ln 1 over root 2, and then that minus at 0, well, we established cos of 0 is 1 and ln 1 is 0, so minus 0. And now I want to factorize out the minus, so here that's double negative, so that's the integral from pi over 4, from 0 to pi over 4 of sine 2x tan x. And now we can further simplify this we can use double angle formula here again. So the double angle formula for sine 2x is 2 sine x cos x. So we have 2 sine x cos x tan x. Now we can simplify this dx. I keep forgetting. Dx, or tan x is sine x over cos x. So we multiply by sine x and divide by cos x. So the cos x's would cancel out and it will become sine squared x. So this becomes plus the integral from 0 to pi over 2 of 2 sine squared x dx. And firstly, I want to rewrite the logarithm in terms of ln4 because the question wants the final answer. The logarithm is in terms of ln4. So, well, 1 over root 2 is 2 to the minus a half. So it would be 4 to the minus a quarter, I believe. Yes. So this is a half ln4 to the minus a quarter, which we can factorize out soon. And this becomes, well, 2 sine squared x using the double angle formula for cos x. Well, cos 2x is equal to 1 minus 2 sine squared x. Oh wait, I just realized I forgot the half here. So that's half, so this 2, this 2 cancels out, so this 2 cancels out. So it's just sine squared x, my bad. So in terms of sine squared x equals half minus half cos 2x. And this is easily integratable now. So now we have this integral. We can take out our quarter. So that's an eighth minus an eighth ln4. And plus from 0 to pi over 4, half x minus a quarter sine 2x from 0 to pi over 4. And now we can evaluate this. So our pi over 4, half x is pi over 8. And then at pi over 4, sine 2x is sine pi over 2, which is 1. So that'll be minus a quarter. And then that's minus 0 plus 0. So this is equal to minus an eighth ln4 plus pi over 8 minus a quarter. And they want it in the form where we factorize 1 over 8 on the outside. So that becomes a quarter pi minus ln4 minus 2. And that is what j is equal to. That's the second part done. And now this last part, it looks a lot trickier. First, let me write it here. So k equals the integral from pi over 4 to pi over 2 of cos 2x plus sine 2x ln cos x plus sine x dx. Now, hence, as the question says, hence evaluate. So we want to use our results from the previous parts to make this question simpler. So we're thinking, how can we rewrite this question, making it more similar to the original two integrals? So first, we can expand this bracket. So k becomes the integral of cos 2x ln cos x plus sine x plus sine 2x ln cos x plus sine x dx. And now we split that up. It already looks a lot more similar to our original two integrals. And now, but the problem right now is this, however, and we want that to be in the terms of cos x, because that's what it was in our original integrals, and we like it to be similar to that. But what we can use is, we can use harmonic identities of the idea is that any addition of cos x plus sine x with any coefficient can be rewritten as one of the functions translated and shifted in some way. So cos x plus sine x equals r cos x minus alpha, denoting alpha denoting a translation and r denoting a stretch. So where r is greater than 0 and alpha is in this what's it called, inequality. So, and now we can our addition formula. So this is r cos x sine x plus, what am I saying? R cos x cos alpha plus r sine x sine alpha. And now we have that. So, and this is equal to sine x plus cos x. And we see that here the coefficient of cos x is r cos alpha, and which is also equal to 1, as the coefficient here is 1. And then it's the same for r sine alpha. The coefficients are both 1. And we can use this to find r and alpha. So first, let's label these equations 1 and 2. What implies that 1, and therefore within our inequality alpha would equal pi over 4. And then if we do 1 squared plus 2 squared, well, that implies that r squared cos squared alpha plus sine squared alpha equals 2, which is 1 squared plus 1 squared. And then cos squared plus sine squared equals 1, so r equals root 2 with the positive root because r is greater than 0. So therefore, we can write cos x plus sine x as root 2 cos x minus pi over 4. And now our integral k becomes the integral from pi over 4 to pi over 2 of 2 cos x minus pi over 4 plus sine 2x ln root 2 cos x minus pi over 4 dx. And now we have this. To go a step further, to make it more similar to our original integral, we can use a u substitution. So if we use the substitution, essentially this should be cos x or cos u or cos whatever. So we want to use the u substitution. It's something I didn't spot immediately, but after I did, I realized that it made sense, right? Because it also changes our limits to the original limits of the integral. So because when x equals pi over 4, u equals 0, and then when x equals pi over 2, du equals pi over 4. du equals dx. X equals u plus pi over 4. U plus pi over 2. And now, using this, k from 0 to pi over 4 of cos 2u plus pi over 2 ln cos u plus sine 2u plus pi over 2 ln cos u du. Now we have this integral. It's looking a lot more similar to what I thought the root 2, my bad. Root 2 cos u. It's looking a lot more similar to our original integrals. But now, if you notice, cos 2u, well, cos 2u plus pi over 2 is identical to minus sine 2u. Now, if I drew the graphs, it'll make sense more. So if I have minus sine, the minus sine graph, which would be that, and then the cos graph is usually like that, something like that. But then if you add pi over 2, you're shifting it in the negative pi over 2 direction. So it would, in the negative x direction by pi over 2, so it would be the same graph. And it's the same thing with sine 2u plus pi over 2. That's also equivalent to cos 2u. And I won't show that because my graphing is horrible. But you get the gist. So now we have the integral 0 to power 4 cos 2u ln root 2 cos u minus sine u ln root 2 cos u du. Now I'm going to split this up into two integrals. So I'm going to get k1 equals cos 2u ln root 2 cos u. And then I want k2 to be minus the integral from 0 to pi over 4 of sine 2u ln root 2 cos u du. And k equals k1 plus k2. So I'm going to find these integrals separately and get back. So first let's start with k1. K1 is this integral. Now using logarithm rules, ln root 2 cos u, well, the logarithm of the product is the sum of the logarithms. So that basically means that this equals ln root 2 plus ln cos u. And that means that this integral becomes cos 2u ln root 2 plus ln cos u. And we can factorize this out. We can split this into two integrals of cos du of cos 2u ln cos u, which is our original integral that we already know the result of, plus the integral from 0 to pi over 2 of ln root 2 cos 2u. And that is an easier integral than any of the previous ones. So we already have this result to be 1 over 8 pi minus 2. And then this is ln root 2 multiplied by the integral of cos 2u, which is a half sine 2u from 0 to... Why do I keep writing pi over 2? It's pi over 4. From 0 to pi over 4. And that is... That is equal to... at pi over 4, sine 2u is... sine pi over 2, which is 1. So a half times 1. And then at 0, sine 2 is 0. So that's just plus a half ln root 2. And then I can get, to make this easier to simplify, I can get ln root 2 in terms of ln 4. So, root 2 equals 4 square root and then square root again, so 4 to the half. So this becomes an eighth. 4 minus 2 plus 1 over 2 ln 4 to the a quarter, which is just 1 over 8 ln 4. So 1/8 ln 4 minus 1/8 ln 4 is 0. So that means K1 is equal to 1/8. So now we have our first result. Now for our second result, K2 equals the integral from 0 to pi over 4. Now we can use a similar thing that we did there, splitting up the logarithm. So ln root 2 plus ln cos u du. And now we can split this up into two integrals. So 0 pi over 4 of sine 2u ln cos u plus ln root 2, the integral 0 pi over 4 of sine 2u du. And my handwriting is suffering right now, but we have this result already, which is 1/4 ln 2 minus 1 plus ln root 2 multiplied by minus a half cos 2u from 0 to pi over 4. Well, at pi over 4, cos 2u is cos pi over 2, which is 0. And at 0, cos 2u is 1, so that's minus a half. So that's 0 minus a half, which is just positive a half. So that whole integral becomes a half, and then this is the same, so equal ln 2 minus 1. And I guess we can put ln root 2 in terms of ln 2 to make this easy to simplify. So ln root 2 equals ln 2 to the half equals half ln 2. So this equals minus a quarter ln 2 minus 1 plus a half times a half ln 2 is a quarter ln 2. So this becomes minus a quarter 2 ln 2 minus 1. As, these two add together. So that's K2. So as K equals K1 plus K2, so K equals, K1 is an eighth pi minus 2, and K2 is minus a quarter 2 ln 2 minus 1. Now let me just expand everything. So an eighth pi minus a quarter minus a half ln 2 plus a quarter, the 2 quarters cancel out, So we are left with 1/8 pi minus 1/2 and then 2, and that's our final answer. Thank you for watching, everyone. I hope you enjoyed. Sorry for all the mistakes, and I will see you in my next post.